All right, so here's some definitions right at the beginning here. We're going to be looking at some application problems, and remember, we're interested in instantaneous rates of change. So the amount that a particular value is changing with respect to time or with respect to something else. Time is a common one, like for example miles per hour. If we want to know the speed at a particular moment in time, that's an instantaneous speed, instantaneous velocity, or an instantaneous rate of change. But when we're talking about business, sometimes we want to know the rate of change of a quantity as the number of units increase or decrease, or at a certain level of production of a certain number of units. And when we're talking about business, we use the word marginal to talk about instantaneous rates of change. So for example, if we're talking about a cost function, we will denote that as C of X. You can see your cost function notation here. The total cost of producing X units of something. And if we want to know the rate at which that cost is changing, like for example, if we know that as we increase the number of units, the cost is going up a lot, that might influence us to not increase the number of units that we're producing. So anyway, when we're talking about the change in the cost, instantaneous change, we're talking about marginal cost. We use the word marginal to mean derivative or instantaneous rate of change, slope of the tangent line. Total revenue is represented with R of X. That's the amount of money that you take in to your coffers, your cash register. And the rate at which that is changing is R prime of X. To figure out your profit in business, you always want to subtract the revenue, the amount you bring into the cash register, minus the costs that you had to pay out, like your rent and so forth. So that's revenue minus cost is your profit function. And your marginal profit would be P prime of X. Now we've learned that we can take derivatives of sums and differences by just taking the derivative of each part. So here we see that the derivative of the profit is the derivative of the revenue minus the derivative of the cost. Okay. All right, so marginal analysis is what we're doing when we're talking about marginal cost, marginal revenue, marginal profit. And it's an important application of calculus to business and economics. Okay, the word marginal refers to rate of change, meaning derivative. It also means slope of the tangent line. To a curve. Okay, so let's look at an example. Here we have a company manufactures fuel tanks for cars. The total weekly cost in dollars of producing X tanks is represented by this function. C of X equals, maybe I should zoom in a bit here, 10,000 plus 90x minus 0.05x squared. We're supposed to find the marginal cost function, find the marginal cost at a production level of 500 tanks per week, and interpret the results. What does it mean in words? Okay, we'll start with that. So first, to find the marginal cost, I want to remind you of our derivative rules, certain derivative rules that are going to be helpful. Okay, so one of them is if you have f of x equal to some constant k, then f prime of x is always going to be 0. Right? Because a constant function is a horizontal line which has a slope of 0. Derivative is just slope. if f of x is equal to x, that's the line y equals x, which has a slope of 1. So f prime of x will be equal to 1. And if f of x is equal to k times x, then it's going to have a slope of k, so f prime of x is going to be equal to k. And if f of x is equal to x to the n power, then we would bring the power at 1 and subtract 1 from it. So f prime of x would be n times x to the n minus 1. These are all rules that might be helpful today and for the rest of the semester. So you should know these, or at least be able to apply these, even if you don't write them out yourself, be able to apply them. So for example here, the cost function is a sum and difference of several different functions. So you're going to apply each of these rules to find the marginal cost. So the first term is 10,000. That's a constant, like f of x equals k, so the derivative is 0. Plus the second term is a number times x, kx. So that means 90x, its slope is going to be 90, just the coefficient of x. Minus, now we have 0.05 times the function x squared. Whenever you have a coefficient times a function, you just leave the coefficient the same and take the derivative of the function. The derivative of x squared, you're going to have to use this power rule we talked about. Bring the power out front and subtract 1 from it. So c prime of x is going to be 90 minus, and then we're going to have 2 times 0.05 is going to be 0.1x. 90 minus 0.1x. All right, so that's how you find the marginal cost function. You just take the derivative of the cost. Now, if they ask you to find the marginal cost at a certain production level, what they're asking you to do is to plug into the marginal cost function. So you're going to take your C prime and you're going to plug into it the value of X, which in this case is 500 tanks. All right, so C prime of 500, we're going to plug into this guy. So we're going to have 90 minus 0.1 times 500. All right, so that is going to be 90 minus 50, which is 40. All right, so the change in the cost, the weekly cost, when we're producing 500, at that moment, the cost per week is increasing by $40 per week. All right, so what we just found is the slope of the tangent line here at 500 units of production. You see the cost function is graphed over here. Let me zoom in a little bit. Let's look at the graph. Okay, so the cost function here, you see the cost is increasing, but back at 200, it was increasing at $70 a week. And at a level of production of 500, it's increasing at $40 per week. So by producing more, our marginal cost is less, the cost per unit, basically. So when we interpret our results from part B above, what does this mean in words? We're talking about that at a level of production, of 500 units per week, the weekly cost is increasing by $40 per week. Okay. Now, you might then predict the cost of the 501st tank because at this moment we're increasing by $40 per unit per week. So if we go up by one more unit, it should increase the cost by about 40. So how would we actually find the cost of the 501st tank? Well, you would have to plug into the original cost function to find how much it costs to produce 501 tanks. Plug into the original cost function to figure out how much it costs for 500 tanks and subtract them. So C of 501 minus C of 500. All right, so that's going to require plugging into a calculator. So get out your calculators if you don't have them out already. We're going to plug into C of X. So we're going to have 10,000 plus 90 times 501 minus 0.05 times 501 squared. That's plugging into the cost function, the value x equals 501. We're going to subtract from that 10,000 plus 90 times 500 minus 0.05 times 500 squared. All right, so I'm going to plug it into my calculator and you plug it into yours. Let's see if we get the same answer. Oops, come on, here we go. Okay, the 10,000s are going to cancel out. So I'm just going to ignore those. So let's see, we're going to have 90 times 501 equals minus, oops. Okay. You guys working on it out there? I'm gonna need you to check my arithmetic. Okay, so what I got is crossing off the 10,000s. I got this guy is 32,539.95, and I got this guy is 32,500. So if you subtract them, you get 39.95. That's the cost of the 501st unit. Now, remember that we said that it was changing by $40 a week, so that 501st unit should have been about $40. Why not exactly 40? Well, let's go back up to this graph here. And remember that this tangent line that occurred at 500 was a little bit steeper than what the function is right after that. So in other words, at 501, we would have had a tangent line that was a little bit less steep. The graph is curving a little bit down. It's not going down, but it's concave down. It's shaped like a cup that's pouring out water. So it's not increasing as quickly as we go, as the x values get larger. So it makes sense that we would have a slight difference, and it would be close to 40, but a little less. And by the way, good job, Taylor, finding that calculation, and thanks for checking for me. All right. You will have problems like this one. And I just want to point out then that the marginal cost of the 500th unit is approximately the cost of the 501st minus the cost of the 500th, which is the exact cost of the 501st unit of production. Okay, so you can estimate the 501st by looking at C prime of 500. Similarly, if I asked you to estimate the cost of the 601st unit, you could find C prime of 600. All right. Another type of problem we're going to be interested in is this one, which talks about the demand equation. A company's market research department recommends the manufacturing new headphone set for iPads based on the following price demand equation. X equals 10,000 minus 1,000 P, where X is the number of headphones retailers are likely to buy at P dollars per headset. Notice that the number of headsets X is going to go down when P goes up, because the more you charge for something, the lower the demand for it will be. So that's why this is called the price demand equation, because it's describing the demand for something as the price changes. If we solve the equation for P, what would we get? So let's solve for P. We have X equals 10,000 minus 1,000 P. To solve for the variable we want, we move any terms that don't have that variable over to the other side. So X minus 10,000 equals negative 1,000 P. Then we're going to divide both sides by negative 1,000. So we're going to have P equals X minus 10,000 divided by negative 1,000. Or you could divide each part by 1,000, and you would get P equals negative 1/1000th of X plus 10. Or X over negative 1,000 plus 10. Okay, so they're asking us to find the domain of the function defined by the price demand equation P. So what is the domain of this function? Well, remember, X represents the number of headphones. Okay, so although this is a line and technically we could have any values of X that we wanted, it doesn't make sense to have less than 0 headphones, right? So I would say that the domain is everything from 0 up to infinity, although technically we probably would only be making whole number headphones. So you could also say the set of all X such that X is an integer greater than or equal to 0. I would accept either. Okay, I'm not sure how specific they're going to be in my math lab, so pay attention to that. The financial department provides a cost function, C of X equal to 7,000 plus 2X. Find C prime of X and then interpret its meaning in words. All right. So remember, we just talked about C prime of x being the marginal cost. And they're asking us to find C prime. So the derivative, so C prime of x we can find by taking the derivative of each term. The derivative of a constant term is 0. The derivative of 2x is just 2. So C prime of x equals 2. Alright, so remember what x represents. X represents the number of headphones, right, that we're producing. And so what this is telling us is that the cost of producing the next headphone is always a constant. It doesn't depend on x. It's just fixed. It's always going to be $2 more for each headphone produced. Or the cost goes up by $2 for each headphone produced. All right, now we're asked to find the revenue function. So in order to understand, remember, revenue is the amount of money that you actually put into your coffers, right? So the amount of money that you're going to get is going to be the price of each unit multiplied by the number of units, right? So if you sell, I actually used to own a pet food shop before. So if you sell dog food bags, for example, and you sell 5 dog food bags for $10 each, then you're going to have $50 in your cash register, right? In this case, the number of units is X, and the price of each unit is going to be P. Remember, we had X times P up here. But we found what P represents in terms of X. We got P by itself, and P was equal to negative 1,000 X plus 1/1000th X rather plus 10. Oops, went too far. So how about if for our revenue function, which is number of units times price per unit, we multiply X times what P is actually equal to, negative 1/1000th of X plus 10. So our revenue function could be written this way, or we could write it as negative 1/1000th of X squared plus 10X. All right, so that's the revenue function. So if we want to know how much money is going to come into our cash register at each level of X, then we can just plug into this function. But we're interested in how that function, how that value of the revenue is changing. Is the revenue increasing as we increase the number of units? Or is there something else going on? And how fast is it increasing? So that's what we're talking about when we talk about R prime of X. So let's find R prime of X. You're always going to want, you are not going to want to take the derivative in this format where it's got a product, where it's factored. We haven't even talked about a rule that allows us to do that yet. There will be one, but it'll always be more complicated than just distributing out and using this version. A polynomial is always easier to take the derivative of. So we're going to look at this version of our revenue function. I'm getting tired of all this red, so let's switch to black here. Maybe blue. Okay. All right, so to find R prime of X, we're going to first focus in on this first term. Remember, the coefficient stays the same when you take the derivative. So negative 1/1000, and then we're going to multiply by the derivative of X squared. That's a power rule, so you're going to bring the 2 out front and subtract 1 from it. Plus, now we're going to look at the derivative of 10x So whenever you just have a coefficient times x, you're just going to get the slope, the coefficient 10. All right, so r prime of x is going to be equal to reducing, we have 2 over 1,000, so that's negative 1 over 500, x plus 10. We were asked to find what the value is when x, what the value of the marginal revenue is when x is 2,000, 5,000, and 7,000. So that's just asking us to plug in. So we need to find r prime of 2,000, r prime of 5,000, and r prime of 7,000 by plugging into the marginal revenue. All right, so once again, get out your calculators. Help me out here. All right, we've got 2,000 divided by 5, well, negative 2,000 divided by 500 is going to be negative 4. And then plus 10 is going to be 6. Let's see, 5,000 divided by 500 is going to be 10, so negative 10 plus 10 is going to be 0. And then 7,000 divided by 500 negative is negative 14, plus 10 is going to be negative 4. Okay, so remember the price goes down as the number of units increases. So that's going to help us to understand what's happening here. The marginal revenue, the change in the revenue per unit, is going to be 6. In other words, when we are talking about X being 2,000, we're going to have the revenue going up by $6 per unit increase. But by the time we get up to production and sale of 5,000 units, our change in our revenue for an increase is actually going to be 0. That means no change, right? So we're selling more units, but not expecting to bring in any more revenue. It's kind of like doing more work for nothing. And then once we get up to 7,000 units, we're actually decreasing the amount of revenue that we're bringing in by $4 per unit. All right, so that's some interesting information. So that might tell you something about where you want your level of production to be. But more important than revenue, the amount of money that you're bringing into your cash register, is your profit, right? Because you have to subtract from the revenue the cost, and that'll give you your profit function. In other words, P of X is equal to R of X minus C of X. So let's see what our profit function looks like. So our profit function, P of X, is going to be our revenue function, which was negative 1 over 1,000 x squared plus 10x, minus our cost function, which, if we look way back up here, was given to us to be 7,000 plus 2x. We're subtracting that, 7,000 plus 2x. So let's simplify a little bit. So we have negative 1 over 1,000 x squared plus 8x, because we have to subtract 2x from 10x, minus 7,000. So let's see what's happening with the profit at some various levels of production. So we want to find the marginal profit, the rate of change of the profit. And the way we're going to do that, P prime of X, marginal just always means take the derivative, is we're going to take the derivative of the profit function here, which is a nice polynomial function. So looking at the first term, the negative 1 over 1,000 is going to stay the same. Okay, and we're going to multiply by the derivative of x squared. Bring the 2 out front and subtract 1 from it. Plus the derivative of 8x is just going to be 8. Plus the derivative of negative 7,000 is going to be 0. All right, let's simplify a little bit. So that's going to be negative 1 over 500 times x plus 8. This is a formula for the change in your profit, the way your profit's changing at any level of production. So let's check and see at a production level of x equals 3,000 units. Okay, we have P prime of 3,000. Plugging into this formula, what's 3,000 divided by 500? That'd be 6, right? So negative 6 plus 8 is going to be 2. So this tells you your profits at this level of x equals 3,000 is going to be $2 per unit. All right, the change in your profit, you're increasing by $2 per unit. The change in the profit at a level of 4,000, 4,000 divided by 500 is what, 8? So we're going to have negative 8 plus 8 equals 0. So at that moment, our profit stops increasing, it looks like. And then let's see what's happening if x happened to be 8,000. 8,000 divided by 500 is going to be 16. So negative 16 plus 8 is negative 8. Ooh, we're losing profits at that production level. Okay. So there's going to be questions that let's review this whole first part here real quick. So let's see, what did we do? Oh, here, all of example 2 here. So whenever you're given something that relates the number of units to the price, that's a demand equation. It'll often be useful to get P by itself. Given the cost function, you can find the marginal cost. You can find the revenue function by multiplying x times the P from the demand equation. Then you take the derivative of that to get the marginal revenue. The profit function can always be found by subtracting the revenue minus the cost. The marginal profit is just the derivative of the profit function. Or we could have, since we had the marginal revenue and the marginal cost, we could have subtracted those as well. Okay, now let's talk about average cost, average revenue, and average profit. So how do you find an average? Like, let's say I told you your scores on the last 2 tests were 90 and 98. How would you find the average of those 2 scores? Well, you would add them together and divide by the number of scores, which would be 2, right? So you'd get 94, which is a number halfway in between the 2. All right. With that in mind, how would you find the average cost? Well, you would take the total cost and divide it by the number of units. Right? So the total cost at a particular number of units and divide it by the number of units, and that gives you your average cost. The symbol we use for average cost is C bar. C bar of x equals C of x over x. Average revenue, same thing. R bar of x is the revenue divided by the number of units. Average profit per unit is going to be P bar P of x over x units. So sometimes we're concerned about the average cost per unit. Sometimes we're interested in how that average cost is changing at any level of production X. So if you're asked to find the marginal average cost, you're first going to find the average cost and then take its derivative. Marginal average revenue, you find the average revenue and then take its derivative. Marginal average profit, you find the average profit and take its derivative. Okay, so in general, to find the average cost, revenue, or profit, all you need to do is divide C, R, or P by X. To find the marginal average cost, revenue, or profit, you're going to first divide C, R, or P by X to get the average, and then 2, take the derivative. Okay, so let's look at an example. All right, it says a small machine shop manufactures drill bits used in the petroleum industry. The manager estimates that the total daily cost in dollars of producing X bits is C of X equals 1,000 plus 25X minus 0.1 X squared. The first thing we're asked to do is to find C bar of X. Do you remember what that's called when there's a bar over it? That's called the average cost function. So to find an average, what do? You divide the cost function by X. Remember, that's what it said up here. Find the average, divide by X. So we take C of X and we divide it by X. In this case, C bar of X is going to be 1,000 plus 25X minus 0.1 X squared, all divided by X. Now that's not a nice form to take the derivative in. In fact, we don't have a rule that tells us how to take the derivative of a quotient, a division problem. So what we always want to do instead, at this point anyway, is if we want to find the marginal average cost, we want to, which I don't really like how this notation turned out because really it's C bar and then with a prime. We want to find the derivative of this. We're going to get it in a form that we know how to take derivatives. So I'm going to divide 1,000 by X. But remember, 1,000 divided by X, this is X to the first power. We can just bring it to the top so it's not division anymore and make it 1,000 X to the negative 1. 1,000 X to the negative 1. We can divide 25X by X and get 25. And we can divide negative 0.1 X squared by X and get negative 0.1 X. All right, so this is not the derivative. This is using algebra to simplify before we actually take the derivative. Now if I want to find the marginal average cost, that's where I take the derivative. So how do you take the derivative? Well, this first term, 1,000 X to the negative 1, we're going to leave the 1,000 the same. We're going to bring the power out front and subtract 1 from it. So the derivative of X to the negative 1 is negative 1X to the negative 2. The next term is 25, that's a constant. Derivatives of constants are 0. And the next term is just a number times X. The coefficient times X, you just have the coefficient. So C bar prime of X, the marginal average cost, is going to be negative 1,000 X to the negative 2 minus 0.1. Or if we don't want to write that with a negative exponent, we can flip it back to the bottom. So negative 1,000 over X squared minus 0.1. All right. Next part, we want to find the average cost of producing 10 units, C bar of 10, and the average cost of marginal average cost, I should say, at 10 units, and interpret the results. All right, so let's find C bar of 10. I'm going to plug into the original version here. Doesn't really matter which one, I just like that one. All right, so C bar of 10 will be 1,000 plus 25 times 10 minus 0.1 times 10 squared, all divided by 10. All right, so I see a question here from Taylor. Why are we taking the derivative? Doesn't it ask for C bar of X? So it asked for both. I know I've got, the screen's a little full here, but part A was to find C bar of X. And then part B was to find C bar prime of X. So those are two different questions, which I'm glad you know that it's two different questions. But we were asked for both. So to find C bar of X, we just divided by X. But to find C bar prime, we have to simplify that algebraically first and then take the derivative. Okay, great. All right, so now on part C, we're just plugging into those two things that we found. So first I'm finding the average cost when X is 10 units. And so we have 1,000 plus 250 minus, let's see, 0.1 times 100 would be 10. So that's going to be what? 1240 over 10. Check my arithmetic, please. So that's $124. All right, so you've got this machine shop and it's costing you $124 to produce X units. Oh, sorry, 10 units. All right. So interpreting the result in words there, the cost on average, the average cost, not the total cost. So it's not like, actually what I said was misleading. It's not that it costs you $124 to produce 10 units. It costs you on average $124 per unit when you're producing 10 units. So you know how the cost of producing the first unit is high because you've got your rent and everything? So if you only produced one unit, that unit might cost $1,000 to produce. Okay, but the 9 units after that only added another $240 to the price, the cost rather. So on average, it comes out to $124 per unit. So the average cost of per unit. This is tiny, isn't it? Let me zoom in. So what we're saying here is that the average cost per unit is $124 each to produce 10 units. Okay. And then what's the marginal average cost of 10 units? So now we're talking about the rate of change, and we're plugging into this formula. C bar prime of 10 is going to be negative 1,000 over 10 squared minus 0.1. So that means C bar prime of 10 is equal to, let's see, 1,000 divided by 100 is 10. So negative 10 minus 0.1. It's going to be negative 10.1. So how do we interpret that? Well, remember, marginal is rate of change, right? This is approximately how much the cost per unit would go down if we increase the number of units by 1. So at this level of production, at X equals 10 units produced, the cost is decreasing, the average cost, I should say. Average cost per unit is decreasing by $10.10. Are you guys checking my arithmetic? Use the results from Part C to estimate the average cost per bit at a production level of 11 bits per day. So remember, if we actually wanted to find the cost per bit at 11 bits per day, we would have to find C bar of 11. I guess I should say the average cost per bit. C bar of 11 minus C bar of 10, but that is approximately C bar prime of 10, the cost of the 11th. So that would be $10 and, oh wait, hold on a sec. Use the results from Part C to estimate the average cost per bit at a production level of 11 bits per day. Yeah, the average cost is changing by $10.10 per unit, so that would be decreasing going down by 1010. So if at 10 it was 124, then we would have 124 minus 1010 would be the average cost per unit, approximately. And that is going to be what? 114 minus 10 cents, 113.90. Okay. So we start with the average cost at a level of 10 and add to it negative 10.10, and that would be the average cost per unit after 11 units. And I think that's the last one for today, yeah. All right, so are there any questions before we wrap it up? All right, so just a quick overview. Remember, we learned that total cost, C of X, total revenue, R of X, total profit is P of X, which is the revenue minus the cost, the amount you put in your register minus how much you spend on your rent, for example. Marginal means instantaneous rate of change or derivative. So whenever you see the word marginal, you just have to take the derivative. Then we talked about the price demand equation, has an X and a P in it. Sometimes you'll need to rearrange that. Then we talked about the average cost. To find the average cost, revenue, or profit, you divide by X. to find the marginal average cost, revenue, or profit, first you find the average, then take its derivative. So you divide by x, then take the derivative. Oops. Okay, we practice doing that. All right, so these are the application problems that you can expect to see on test 1. We've now finished chapter 2. So we have our test due on June 4th. And please make sure to check with the testing center for their hours of operation. It's best if you go ahead and register for your test and make an appointment in advance, just in case the testing center is very busy when you get there. I don't recommend waiting until the very last day, because if something should go wrong, it's good to have another day to reschedule your exam. I have had the situation in the past where students have shown up a little too late to take their exam. Remember, you have to come an hour and a half before the testing center actually closes, and if there's a little bit of a line and you have to wait, you'll cut into your test time even then. So I would come at least a few hours before the testing center closes. Remember that even though we're not meeting in person, you can still contact me. I showed you at the beginning of the lesson that we have this OneNote link where I can post solutions to Ask My Instructor questions, and I have been receiving some good questions. Not a lot of them, but I have been receiving them from your class, so thank you, and keep that up. I'm going to go ahead and log off now, and if you have any questions, you can always email or Skype me. Okay? All right. Thanks, guys.